Welcome, everybody, to the Red Room, to Parameters for Understanding Uncertainty. This is the fourth and final interdisciplinary seminar in the circle, or cycle. And I'm really delighted that you're all here. It's called Traces of the Not Yet Known. We have some very interesting people with us today to help us to probe this question. I'm Rebecca Collins. I'm an artist investigator, and I've been in B14, the office just next to here, since January 2022, and I'm sort of slowly leaving, sort of in the next few weeks or so. So this is sort of the beginning of the end, sort of closing something that is sort of been kind of ongoing. But I come from the University of Edinburgh, where I'm lecturer in contemporary art theory, and I've been here thanks to a grant I received from the Royal Society of Edinburgh to finance this research project. The other sessions, I think some of you have been to the other sessions. Some of the people who presented at those sessions are here, and those are available online if you want to watch those. But I want to maybe just sort of focus on being here. I brought this with me in case we need to just change our particles for a minute. Just going to keep this around. I'd like to introduce our speakers today. Interlocutors, accompaniments, people who are with us to talk about questions that don't necessarily have any answers, but maybe have some more questions. So we have Michael Schwab, who's here at the front. At some point, he will hopefully turn around so you can see him. But he's here. I'm very grateful that he's here for many reasons. Partly because I first came across his work and his efforts when I was doing my PhD in 2010, and at the time I was working from a small cupboard in a library in Aberystwyth in Wales. And it was useful for me to understand that the Journal of Artistic Research, which he founded and is the editor of, and it's in a really important platform for publishing artistic research in its multiple dimensions, that was a thing that was occurring. And actually yesterday when Michael arrived, he phoned me from a corridor, which seems to somehow be appropriate. Fortunately, he's here, he's not in a corridor, but he's an artist researcher. And he has some experience, some powers in this area of thinking through the nexus of art and science. He handed me this really big book earlier, and I'm going to sort of pass this around for you to look at during the session. This is the instruction he's given me. We also have Alberto Casas, who is here, a theoretical physicist, also someone who I admire a lot, who's been an important figure for me, and someone whose work I've kind of overheard in many ways, and also someone whose work I've been reading this year after his book came out, The Quantum Revolution. And I really felt that to bring these two people, these two energies together in this context would be interesting. We don't know what's going to happen. We are really kind of at the limit of certainty this time. So please be with us. We're in the red room as opposed to the blue room, which has its own kind of setup, and you're very much invited more than ever this time to really be part of the discussion, and to interrupt and to ask a question or to say something. And so to kind of begin that gesture, I am actually going to ask everybody just to move one row forwards. Pepe, I think you've moved one row backwards, but okay. So I think we're almost ready to start. The only other thing I want to say before this begins is that normally after these sessions we have had a coffee and cake moment, but today we're going to have a slightly different moment because there is an exhibition called Listening to Dark Matter, Escuchar la Materia Oscura, which is in the Plaza Mayor, which is it's actually a sort of 7-minute walk towards the center of campus. And there are sort of other energies operating, but this is an exhibition that I've kind of worked intensively on since really last summer and perhaps even before that. David Cerdeño, who's the scientific host of all of this and somehow responsible for everything that is going on. He had a big part to play in that. So I brought a flyer so that we will know we'll know what to look for when we get there. And I would really like to share that with all of you and in a kind of procession format. So rather than kind of hanging out on coffee, we're going to kind of extend the conversation in a promenade situation. So I think we're kind of close to starting. If that sounds good. Okay.
Good morning to everybody. Can you hear me well? Okay. Since the title of the session, the generic title is Traces of the Not Yet Known, I'm going to talk mainly about what I know, which is physics. So I'm going to talk about knowns and unknowns in physics. So, well, I have to apologize to my colleagues, to the physicists which are in the room, because you're going to get bored with me, because I'm not going to say anything that you don't know already. But fortunately, it's also Michael, so you are going to enjoy the session, I think. So, when we talk about knowns and unknowns, a classification which has somehow become standard is the following. So, classification. First, there are knowns. That is, things that we know. Okay. Then there are known unknowns. Things that we know that we don't know. We will find examples of these things later. And finally, we have unknown unknowns. Things that we don't know that we don't know. Well, maybe a first thing to say here, well, somehow the business of science, in particular in physics, is to promote facts from the unknown categories to the known categories, to deepen in our knowledge about nature. So we can say that the enterprise of science is to promote these facts, to known facts, and to promote these facts, also these unknown unknowns, to known knowns, or at least to known unknowns. But what I was going to say is that in science in general, in physics in particular, there are no sacred truths. Everything is subject to revision if an experiment says that the theory or the fact is not as we thought. So we should put quotations here. And we will find also examples later. So what is the strategy of, maybe I wrote to the right, okay. What is the strategy in science to gain knowledge about nature in this sense? Well, the strategy is what is usually called the scientific method. So there are many books and essays about scientific method, and I'm not going, of course, to enter in that deep, but I'm going to discuss the scientific method as you can find it in the usual textbooks in high school. So the scientific method that you can find in those books goes more or less like this. First, what happens?
That is not working because there is no...
It's not working?
No, it's okay. Okay.
So first you start with an observation, something that you don't understand or something that you cannot explain with the theories that you have at hand. Then, motivated by that observation, please, David, can you pass? No.
I'm not...
I know what is going on.
I don't know what's going on.
Okay, no problem. From that observation, you formulate an hypothesis. And then, to check the hypothesis, you design an experiment to see if the hypothesis works or doesn't work. If the experiment fails, that means it gives you some results which are not the results that should be derived from the hypothesis, you have to reconsider your hypothesis. Either you throw it away, or maybe you can modify it in such a way that at the end the experiment endorses your hypothesis. In that case, when you have already an hypothesis that passes the test of the experiment, then you can say that you have a theory, more or less, something which has somehow checked in some contexts. And even in some books, you can see that they say that if the theory is checked in many contexts and many times and with flying colors, then you have already checked truth, and this is a law. But of course, as we have already mentioned, there are no sacred truths in science, so we can throw away this law, please. Okay. Okay, but otherwise this scheme seems quite reasonable, and in fact quite often scientific papers are organized in such a way that they correspond more or less to this scheme. Okay, that's good, this is nice, but this is not what happens in reality. Reality is much more chaotic, much more free, but also much more interesting, I think. So in reality, let's see what happens. Yes, scientists work in all the fronts at the same time. And in fact, there is a feedback between observation and hypothesis and experiment and theory. You are working at the same time. So what is the essence of scientific method? Well, I think that the essence of the scientific method is the feedback between theory and experiment. With experiments, you will have a proliferation of theories, as maybe it used to happen in philosophy, but you don't know what is the correct one. So in science, the way to see or to explore what is the correct hypothesis is to ask nature, and the way to ask nature is to perform a clever experiment. On the other hand, if you don't have a theory, you are not going to design clever experiments, and you are not going to interpret the experiments in an efficient way. So this feedback is what is the essence of science. And in my opinion, you cannot say much more about what is going on in science. There is a feedback between theory and experiment. Okay, so in our case, since the generic title of the session is Traces of the Unknown, we are going to focus in one of these ingredients, which is the hypothesis. Okay, because when a physicist formulates an hypothesis, it's because he or she has some clue, some trace of something that has to be explained. And this is the traces of the unknown. So, according to the traditional scheme that we have presented, the hypotheses are based on observation. And in fact, this is what happens very often. I mean, the motivation for a physicist to put forward an hypothesis is some observation that cannot be explained. So let me illustrate this with an example. So where should I write? Here? Okay. So my example is the following. Yeah, around 1840, there was an observation that puzzled physicists at that time, which was the following. You have the sun, and at that time, the most distant planet, known planet, was Uranus, which was following an orbit around the sun. But the puzzling observation was that Uranus apparently followed correctly Newton's law that describes the orbits of planets, but at some moments it accelerated, completely in contradiction with Newton's law, and then it slowed down after that. And people didn't understand why this happened. Some people even thought that maybe Newton's law was starting to fail at long distances, because Uranus was the most distant planet. This is Uranus. Okay. Then at that time, Leverrier proposed another hypothesis, which was that the anomalies in the orbit of Uranus were motivated by another planet, more distant planet, that he named Neptune. And in fact, this was the correct hypothesis, because a few years later, Neptune, this planet, was discovered at the place where Leverrier had predicted. So the hypothesis passed the experimental test. Okay, so this is a case where the hypothesis was motivated by an observation, by an unexplained observation. Notice that in this process, people knew something that they didn't know, an unknown, which was the existence of an extra planet. Okay, and this is typical. When you discover something new, usually it comes with some extra bonus, some things that you didn't know. And we also find some examples later. Now let me put another example of this, a more modern example. I can write maybe here. Okay. And this example, which is very similar to the Uranus case, is the fact of the dark matter. In this case, for the dark matter, people, in particular Vera Rubin and Ken Ford in the 60s and the 70s of the past century, they saw, although there were already indications, but they studied in great detail the motion of stars around a galaxy. You have here a galaxy, and this is a peripheral star, and they studied the motion of these stars. And they discovered that these stars were too fast, were going too fast, but like 10 times faster than they should, because the orbit is generated or is described by the mass of the galaxy. So this was a problem because the galaxy apparently had not the mass enough to produce this motion of the stars. So the most accepted hypothesis to understand this was that there was some kind of invisible matter around the galaxy, which in fact has to be like 6 times more abundant than ordinary matter. That was the cause of this strange motion of the stars. There were other hypotheses, and in the case of Uranus, there were people that said, well, maybe at long distances, Newton's law started to fail. But right now we have overwhelming evidence that the correct hypothesis is the one of the dark matter, that there is something there that we don't see yet, which is the responsible for this motion of the stars. So this is quite similar to the Neptune case. The only difference is that we have not detected dark matter directly yet, and this is a problem. Even it could be wrong, the hypothesis of dark matter, although most of the physicists think that there is really something there. Okay, in this case, the discovery is much more important than in the case of Neptune. Neptune is just another planet, but this is not only more abundant than ordinary matter, but also is a different kind of matter. So it's very probable that when we discover the nature of dark matter, that will also come with extra bonuses, that we will learn new things about nature that we don't know now, that even that we don't know that we don't know. We'll see. Okay, so this is the traditional scheme, okay? But to finish this term, let me say that in practice, physicists can be motivated by other causes, they can have a different motivation to put forward hypotheses. For instance, a possibility is the lack of mathematical consistency of the existing theories. Other possibility is the quest for simplicity in the theories, or even the quest of beauty, for beauty. In fact, there are many motivations for a physicist to put forward an hypothesis. In fact, scientists feel completely free at the time of formulate an hypothesis, as free as a philosopher or even as a poet. There is no restriction for your imagination. But this is not completely true. The annoyance here is that your hypotheses have to pass the test of the experiment. If not, they are just an speculation. And if they don't pass the test of the experiment, they are false, simply. So this is a problem. Actually, we have already many data, many experiments that have been performed in the last century, in the last centuries. We have thousands, hundreds and thousands of data. So the problem for physicists is that when they think of an hypothesis, they must be sure at the beginning, from the beginning, that this is not contradictory with the facts that we already know about nature. And this is difficult because there are many data, sometimes with high levels of precision, and your hypothesis must be consistent with everything. If not, your hypothesis is dead from the beginning. So later we will see examples of these other motivations for hypotheses, these other traces for the of the unknown, the quest for simplicity, the lack of mathematical consistency, and the quest for beauty. Okay, so now it's your turn.
Thank you. This is not my field, and I don't have the luxury of starting with something known, which is a discipline. So when we enter research in art, we don't know what that actually is. There's a lot of speculation about this. So in the first part of my presentation, I want to just refer to the fact that there's an unknown unknown within the whole debate where art sits in this context. To illustrate this, I've put this image forward, which is just an illustration of a story that Pliny told about this contest of painters, where Zeuxis painting fools the birds. The birds fly down and want to pick the grapes of the painting because they're so real. And Parrhasius painted a curtain, and Zeuxis was asking, can you remove the curtain so I can see your painting? And the painting was the curtain. So he could fool the artist and not just the birds in with his painting. The big point is, though, that historically speaking, cases have been made for art to not tell the truth, to deceive the eye, to tempt us into believing things as real which aren't real. In Plato, we've got loads of ideas about this, where the painting of a table is a copy of an idea. So you kind of are in these derivatives, right? So it's really only at a fairly late stage, and I would just guess, let's take 1800 as a starting point, where it became credible to associate art with knowledge or epistemology in the widest sense. Of course, there are various relevant discussions in theology as well before those points and within Renaissance. But let's just pick that as a good starting point. But let's focus on what I would call the contemporary moment. So the question I'm raising is, how much of that history that we know and we can imagine matters to where we are today in looking at what art can or can't do in the context of research, right? So if this is my time axis, right, and I'm starting at 1800 for my liking, I would say that roughly in the middle of the 19th century, you get this belief, you might say, or this topic that art embodies knowledge, that artists have a special knowledge which they contribute to the world, right? But this model actually isn't really super dominant anymore, so there's a bit of a fading happening with that. We still do, in the widest sense, associate art making with knowledge, but in terms of its contribution, where it sits in a wider sense, it isn't really as dominant in the discourse anymore. We don't just say, we all know because we're artists, right? Something else has to happen. If you're looking at a later stage of this development, you'd say that maybe in the mid 20th century, a dominant topic was creative research. You had a lot of discussion around, how would art actually engage its creativity to further innovation in all sorts of ways, in particular media art, but also around notions of conceptual art and other forms. So we have this creativity as a key element, which didn't really matter so much initially, but more importantly, there's a switch from knowledge to research within those topics. I would argue that today we may not know what we don't know, but we are open to research as a paradigm within which we are working, regardless whether or not we're achieving a conversion of unknowns into knowns. So there's a bit of a different starting point there. As this happens, this model of creativity is somehow faded as well, because it's associated with avant-gardism, progression. We're gonna change the world by being creative, and that's become a bit of a less credible story in art anymore. We have not really this belief, as they had in the 20th century, that art might end, the last painting would be made, or that conceptual art would dominate everything else. It's not like this anymore for contemporary artists. Within the more research dominated discourse, we have this phenomenon that appeared within the late 1990s, which we would call practice-based research or practice-led research. So that we would argue, because artists, in brackets, and also other researchers would get their hands dirty in practice with materials, do they develop new understandings and new knowledges. And this would lead, in a later stage, you might say, to knowledge proper, right? There's a problem in this, that actually at this point in time, so we are here like in the 1990s, say, this idea that artists were only manual workers that would kind of form clay into sculptures or put paint on canvas isn't really dominant in art anymore. So the practice space is there, you know, people are getting their hands dirty, but it's not really defining their art. It's an important element in art practice. So we've got at the very end of this another paradigm arising, which is the paradigm of artistic research. Now, in this word, I would argue, we've got, in a way, two problematic terms. First of all, the artistic doesn't really give away a lot as to what it specifically is it contributes. So it is neither in the work as such, it's not creative as such, it's not really based on the practice that is being done. There's a value in this specific type of research that's hidden in this word artistic, which in fact sounds a bit art-like, so like research that is art-like, but not art proper. So there's a bit of an issue around this. And research, we likewise don't quite know. We're making new things, but at what point is that converting into knowledge? It's a big question as well. So we've got that situation that there's a massive debate and a massive investments taking place here, but none of these historical concepts are actually really sufficient to explain what's happening. Okay. As this is happening, we have other developments within the history of art, less concerned with epistemology and art's contribution to knowledge, which are around notions of art in more general terms. One important moment, again, I would say in the 19th century, is that we first of all started talking about art in a singular, that there is something like art as a field that would encapsulate all these different forms of art, music, painting, poetry. And we also know that they don't really operate in the same synchronous moment. So we have different approaches to art making at different points in time. Right? We also have then in the 20th century a focus on medium, where either it's the medium specificity of painting, we think about Greenberg and Pollock, how we talked about them, but also then Marshall McLuhan's theories of medium, where it was claimed, he was arguing that the medium was the message, or in a misspelling book title, the massage. Like, it's all about medium at this point, right? And then we've got this moment where it's post-medium or post-conceptual, if the concept is your medium in brackets, where we are moving beyond that. And again, who tells us what that specifically is? We've got all sorts of examples within contemporary art that is digesting all these histories in a position of contemporary art that is less and less defined. It's not more and more defined. It's very specific for a practitioner side, but conceptually, it's a very, very difficult process. So rather than moving from something that is, in a way, unknown to a better and better definition of what art is today, we are moving into a more complex understanding of art that people painstakingly learn as they go through higher education in art or in experience of museums and concerts. What is it specifically here that makes this piece work? And this is not happening on a level of definition. It's nothing I can learn and apply. It is something that we have to think through and see how that applies in any particular case. In particular, if you do research claims, right? Because if you're saying, not only have I done this piece, but also it's got this epistemic importance, we're in a really difficult situation, because on what ground would you make this claim, right? So this is where we find ourselves at the beginning of all of this, that there is no basis upon which to even raise that claim. And secondly, we have to find strategies through which we can register this claim in an audience, for example, that you would say at some point, oh, actually, yes, I see this as art. Oh, and yes, I see this as contribution to knowledge. Right? I will pass to you again.
Well, now in my turn, I will continue going upwards, okay? But a little bit also downwards, as you will see. So, I was mentioning that when scientists formulate hypotheses, they can be based on observation, but also, for instance, on the lack of mathematical consistency. So let me put an example of this. Around, say, in the middle 80s, there were a lot of known phenomena in electromagnetism, I mean, electric and magnetic phenomena, which were well described by a handful of laws, in particular, the Gauss's law, in fact, two laws there, Faraday's, Faraday's law, and Ampere's law. So this was great, but there was a person, James Maxwell, Scottish physicist, that noticed that these laws are inconsistent between them. I mean, the mathematical structure is not consistent between the laws. So in 1865, he reformulated these equations and modified, in particular, this Ampere's equation, adding a term so that the laws were already consistent with each other. And these are the famous Maxwell equations. Maxwell laws or Maxwell equations, which is a very important moment in the history of physics. So Maxwell equations, in fact, passed the test of the experiment. They describe wonderfully electromagnetism, but there is something else. From these equations, notice that these equations were formulated not by any observation that was in contradiction with these laws, just for the mathematical, from the mathematical inconsistency between them. So he noticed from his equations that some new phenomena that had not been observed yet should be present in nature. In particular, electromagnetic waves. He predicted that there should be electromagnetic waves, and in fact there are, and we use them every day, for instance when we talk through a smartphone. Not only that, he calculated the velocity of these electromagnetic waves, and he found that the velocity of the electromagnetic waves is precisely the speed of light. So he was he was the first person in history to understand the nature of light. Light is an electromagnetic wave. Again, these are extra bonuses that came with this progress in our fundamental understanding of nature of phenomena. In this case, electromagnetic waves, you can see that is an unknown unknown. It was an unknown unknown, and light was a known unknown because everybody was conscious of light, but nobody knew what light was. So this was great, but there was a problem. Some years later, people noticed that Maxwell equations, well, probably Maxwell already noticed that, in fact he noticed, that most Maxwell equations are not consistent with another fundamental piece of physics, which is Newtonian mechanics. The The principle on which Newtonian and Galilean mechanics are based on are inconsistent with Maxwell equations. So there was a lot of work trying to make these two things consistent. It was the time where physicists made the proposal of some ether that was around that could make these things consistent. But finally, this inconsistency was solved by the theory of relativity of Einstein, in particular special relativity. So I'm going to put here relativity as in general. This was proposed, special relativity, in 1905. And this theory, this new theory, was able to make sense, to make consistent these two pieces of knowledge. In fact, what Einstein did was to keep Maxwell equations as they are, and he modified the sacred Newtonian equations of classical mechanics. Again, as you can see, Einstein was mainly motivated by a mathematical inconsistency. And again, this came with an extra bonus. There were now some new facts, or some facts of nature that we didn't know that we didn't know. In particular, probably the most important one is the equivalence between mass and energy, the famous Einstein equation, E equals to mc squared. This comes from this theory, from special relativity. And of course, nobody knew that energy and mass were equivalent concepts. So the story continues, because at the time when relativity was proposed, another revolutionary theory was also put forward, which was quantum mechanics. And in fact, special relativity at the beginning was inconsistent with quantum mechanics. This was solved with quantum field theory. There is a long story here, but to make this long story short, I will say that at the moment, the most general version of relativity, which is general relativity, which together with quantum mechanics are the two pillars of modern physics, these two fundamental theories, and wonderful theories, the fact is that they are inconsistent each other. So the work of many physicists, fundamental physicists around the world, is to find a theory which can make quantum mechanics consistent with general relativity, which by the way is also a theory of gravity, of gravitation. So many people are working, people in this room for instance, are working in theories that are trying to make consistent quantum mechanics with gravitation or with general relativity. So far, there are hypotheses, but there is no any hypothesis that has passed the test of experiment. So we are here at this moment. The most important hypothesis in this sense is string theory. String theory has the potential to unify these two concepts, to make consistent general relativity with quantum mechanics. The problem with string theory is that it's very difficult to test. That's the problem. And as we know, a theory can be very beautiful, but as long as you have not tested experimentally, it is a speculation. So string theory is a speculation. It's a beautiful speculation. It's an extremely interesting theory, but it's a speculation. That's the point where we are now. Let me comment something, taking the point of Michael, which is the following. I was saying that the enterprise of physics is to promote unknown unknowns and known unknowns to known knowns. This is true, okay? But sometimes we find that things that we thought we know or we knew, then we realize that we really understand well. And here we have an example. When Maxwell enunciated his equations, it became very clear that light was a wave, an electromagnetic wave, but a wave after all. And in fact, in the 17th century, there was a big debate about nature of light. Newton claimed that, or he thought that light was made of particles, small particles. Other physicists, like Huygens, thought that it was made, it was a wave. They thought light was a wave. And this debate seemed to be quite settled in the 18th century and in the 19th century, because experiments seemed to give in favor of the ondulatory theory, that light is a wave. After this discovery by Maxwell, it became very clear that light was an electromagnetic wave, not small particles. However, with quantum mechanics, we have learned that the nature of light, in fact, has both aspects. It's a wave, but also they are particles. In quantum mechanics, both natures, wave and particle, are consistent, are part of the same entity. And this happens for light and also for particles. Light is a wave, but also they are particles. It's made of particles. Photons are the particles of light. And in the same way, electrons, for instance, are particles, but also they behave as waves. So both aspects, both traits are consistent and are consistently described by quantum mechanics. So somehow, at the end, what we thought at the end of the 19th century about light, it was very clear that it was a wave, that had to be revised. It was not that clear, after all. And somehow, history has said that both Huygens and Newton were right. Although I have to say that the particles that Newton had in mind are not the photons that we know right now. Okay, so I finish here this part.
I was left at this point, and my key question really is, how do we know? So if the starting point is we've lost the identity of the object we're looking at, we are struggling with a clear image of what ingredients specifically are needed to make contemporary art today. There are no objective descriptions for this. And there is a growing sense of it contributing to knowledge, but we are not describing that either well. How do we know about this? How are we in this situation even that we claim there is something happening? First of all, I have to say there are different schools of thoughts here, so I can only refer to my school of thought. But it's important to me to say this, because there's a lot of people within this field who are very much interested in the practice-based, or you might also embodiedness of artistic research. Isn't quite my thing, but there's a focus in the field, and you may connect this with the traditional discussion of aesthetics, right? That within 19th century philosophy, for example, there's a particular emphasis on aesthetic, and the human, also in sciences, moves into the foreground. However, I would argue that the contemporary moment isn't really fully explainable through notion of aesthetics. It's not so much that somebody goes somewhere and experiences, but you are a maker. You get what happens by making it or remaking the work in your head, so to speak. You're putting yourself in a position of making it. So, and this is like one of the points that links us, is that rather than looking at this as experience, I would look at contemporary art as experiment. People are experimenting with the practice. They're experimenting with you as a visitor to a particular exhibition or a particular performance. And this experimentation has effects on you in your understanding as well as in your affects, right? And it's these effects that are being evaluated in this process. If there are no effects of that experiment that's carried out on you, then it would have failed in this sense that it just leaves us cold, it doesn't do anything. And it may have effects in terms of we see the world differently by having experienced this. This is also possible, you know, and I leave, say, a film, or I leave a performance or an exhibition, and I see the world differently. Somehow it changed my perception. It changed my understanding of what it is that we live in, right? So in order to try to make this epistemological case, I've looked at the history of science and was trying to work out what it is that I could borrow from a scientific background where we get certain similarities. Now I would have to move this up, and I don't know if you want to start this video again, but no, it goes this way around. You can do it straight on top here. And I'm referring in particular to Hans-Jörg Reinberger's work on historical epistemology, where he basically went to a lab and research group and looked in detail at the process. What is it they did really? So you may remember the diagram from you here, like this confusion of what's first, what's last, where's observation, where's the hypothesis in this. So the messiness of this, he was trying to trace in this research group, right? And I personally would simply say, and not as neatly as you put it, we have basically a whole mess happening in a lab, you know, loads of things, and people are waiting for traces, little moments where something seems to happen. Glitches, you might say, in an experiment. Little moments of there's something happening that we didn't anticipate. Yeah? In most cases, these glitches are dirt on some lab equipment. There are some other elements that can be explained later. But if you happen to find that there is an aspect here that you just can't explain away, it must be a phenomenon that has some value in further investigation, right? And these phenomena that are not yet known at this moment, but you cannot explain them away, he calls epistemic things. They're not yet knowledge, but they can't be explained away as phenomena. And so we have a process by which you're focusing on amplifying this specific phenomenon through experiments, further experiments, and conceptual work, and calculations and modelings. So there's a whole scientific process in place that stabilizes and creates representations of the epistemic thing that is not itself yet a representation, right? Until, you might say, it passes a certain threshold, so it's stabilized, we understand it now, we can write about it. We can publish a paper and say, you know, this is the equation that explains this. Important to me is, at this moment, that within the sciences, as he describes it, Reinberger describes this, we've got knowledge entities that are not representational yet. They exist, we're working with them, but they are in a way half knowledge, or they are hunches that this might turn into something, but we don't know it yet. And these epistemic things have their knowledge in the future. This knowledge isn't already had. We don't know yet what they are, but they're projecting this future knowledge. So this temporality is built into the system. And if it works, they make history. They change the world the way we know it, right? As you described it now. The world has changed through these better representations of these epistemic things. Now, important to me is this process here. So when we're looking at contemporary art, and we are saying we don't have a representation of what it is that's art, it still expresses itself as art, it still expresses itself as research, but it's a complex process where this experiment that somebody puts in front of you, will register, or it will create a future in which it will register, but it's not yet established as such. It's might say, a hypothesis in this sense. So, if I was to try to look at this process in a little bit more detail, so we're coming here from the experiment into this amplification of traces. First of all, importantly, it's not a single trace, right? It's a whole set of traces that are, you might say, differential because they don't happen all at the same place, they don't happen at the same time. So it's quite of a messy situation from which you are coming to an understanding there's an identity happening here, something you can focus on. So there's distribution in place. And secondly, normally we believe you have this, as I said, and you kind of have a process of writing this up later in a document of sorts. Now in art, we have an example from the history of art. This is Duchamp's Fountain from 1917, where it's a fundamental piece for the understanding of contemporary art, where it's not like this. What we have is that Duchamp had this ready-made urinal turned on its side, brought to an exhibition and said, right, here's a piece of art. And they said, no, we're going to show it. It's not art, right? He went to Alfred Stieglitz in New York, had it photographed and was published in a magazine. You can see this, the Blind Man magazine here, in front of a painting on a plinth, much too small for it, with some text around it. And that magazine publication registered the piece as art. And later it was displayed in a museum, as you can see now in the Museum of Modern Art. The articulation precedes the artwork. So in some sense, this whole idea that we establish it and then we publish about it is turned on its head. In fact, it is established as what it is by articulating it in this process. So for us, the work itself has to articulate itself as contemporary art and also as research if you're moving in this dimension, which means that in some sense it will create its own ground on which you as a visitor to an exhibition, say, would make that judgment whether or not it's the case. In some sense, these historical examples have done similar things. Only on their ground, once you accept the outcomes, can you see the world in this way. If you don't, you might be a skeptic and you'd say, but, and then you're bringing on in different explanations from the past that you claim are still holding. You will insist, say, art has to operate like this, or we're still in a Newtonian space, or whatever it might be, right? So this complex process of managing that a piece of whiteware from a bathroom store counts as a piece of art, the manufacture not so much of the thing, but of its registration as contribution, has become key to this whole field. Okay, and when you enter any of these exhibitions or any presentations around artistic research, the question I would ask is, can you at least sense, or maybe even with the work that you see, reach a point where you say, yes, I can see this, it's happening at this point. If you're before that moment, you might still have a sense of, yeah, I see what this is about, but I don't quite register it as being an artwork or as being a contribution to knowledge. Now here's an example of a sugar bowl and a creamer, which were made on the basis of some scientific data, e.g. ski scans of my brain. Now, the question is, are these now proper art objects or design objects, or are they scientific models that are describing my brain activity? Because in a way, they are three-dimensional representations of my brain activity. Now, there is a whole zone around it where we don't have to make up our minds as to what the status of this is, but there are speculations. There are speculations as, do you see this as art? Do you see this as a model? And if you're operating in this area, then how I'm going to present this, how I'm going to speak about this, how I will guide you into a process where you might even see both, and what does this mean for your understanding of brain activity or sugar bowls and creamer jugs, is a different matter. So the whole strategies developed in the last 100 years in art that do this all the time. Publication and presentation are not secondary elements anymore in the making process. They are the site where the stuff is made. Engaging with articulation as a primary basis for practice is an important element in there. Experience is important, but first of all, it's a speculation that this might work. This might actually create effects in you and in your thinking that will change the way you see the world. And I pass over to you at this moment.
Okay, so now to finish my part, I'm gonna talk about the last point I put before, which has to do also with aesthetics somehow. So it's more, maybe it's more connected to you are talking about, no? Remember that we were mentioning possible motivations to formulate an hypothesis, an unexplained observation, or maybe the lack of mathematical or logical consistency between theories. But we also put another possibility, which is the lack of simplicity or the lack of beauty. Now, of course, to talk about beauty after these other motivations, an unexplained observation or the lack of mathematical consistency could seem almost a frivolity, but it is not. In fact, the quest for simplicity and for the quest for beauty has been a driving force in the progress of theoretical physics. And let me illustrate this with some examples. So put yourself in 1666. At that moment, there were some phenomena that were more or less understood. For instance, the falling bodies were well described by Galileo's theory. All bodies or freely falling bodies on the Earth fall with the same acceleration. Okay? This is Galileo's theory. Also, people knew since centuries before the motion of the moon. This was very well known, of course. The period of the moon is 27 years. Sorry, 27 days. And also, people knew a lot about the motion of planets. And in fact, the motion of planets was very well described by the laws of Kepler. This was the situation, more or less. Okay, at that time, in this year, the young Isaac Newton, he was 23 years old, he had a great intuition. He was a genius. And was the following, was that these two facts, the fact that an apple is falling from an apple tree and the fact that the moon is rotating around the Earth, in fact were aspects of the same cause. They were in fact the same phenomenon. So he formulated what is called as the Newton's law of gravitation, and with this simple law it's possible to describe at the same time the motion of the falling bodies, that is Galileo's theory, and the motion of the moon. In fact, he was able not only to describe these two things, but also to derive the period of the moon. The period of the moon is 27 days, but why? Well, he could derive from his equation that the period of the moon should be 27 days. This is very interesting because probably, I don't know, but probably before Newton, nobody even thought about why the period of the moon is 27 days. Sometimes you need a genius to ask clever questions. Okay, very well, but not only that. Sometime later, he also, using the same law, was able to describe the motion of planets. That is, to derive Kepler's laws and also go beyond Kepler's laws. By the way, to do that, he had to develop a new branch of mathematics, which is differential calculus, which is an extremely rich and fruitful branch of mathematics. So he was a genius in physics and also in mathematics. Okay, so in fact, there was nothing inconsistent. There was not any lack of consistency between the theories. And there was not any observation that could not be explained in principle, or which was contradictory with these laws. However, he had intuition that nature must be simpler than it seemed, and that some facts that seemed to be unrelated, that they were in fact related. Now, I'm going to give you an example of the same thing, in fact, or in a sense, but in modern physics. So, can I write here, for instance? Yeah. Okay. Think about elementary particles. The first elementary particle to be discovered was the electron. The electron was discovered, I'm going to put the electron here, was discovered in 1897 by Thomson. It was the first particle, elementary particle to be discovered. Okay. After the electron, there came another particles, in particular proton and neutron. But many years later, it was understood that proton and neutron are not in fact elementary particles. They are composed of other particles called quarks. A proton, for instance, is made of 2 U quarks and 1 D quark. A neutron is made of 1 U quark and 2 D quarks. So as far as we know, the elementary particles are the quarks, not the proton and the neutron. So I should put in this list also the D quark and the U quark, which are the initials of up and down. Also at that time it was formulated the hypothesis that there was a fourth particle which was called the neutrino. That in fact was discovered 26 years later, in 1956. Okay, this family of particles, you can call this the first family of particles, or the family of the electron. Family of the electron. Very well. So apparently all the ordinary matter was described by these particles. But something happened. In 1937, people discovered a new particle, which was the muon. The mu particle, or muon. The muon is almost identical to the electron. Almost, it has the same properties, except that its mass is 200 times bigger, larger than the electron one. Otherwise, it's almost exactly as the electron. In fact, it has also a couple of quarks called strange and charm, and also it has its own neutrino. To distinguish them, this is the muonic neutrino, and this is the electronic neutrino. Electron neutrino, muon neutrino. The only difference, the only important difference between these particles and these ones is that these particles are heavier. The muon is 200 times heavier than the electron, for instance. Otherwise, they are exactly as fundamental as these ones. So this is the second family. And there is a third family, which is the family of tau. Tau again is a particle identical, almost identical to the muon and the electron, but is 17 times heavier than the muon. That's the only difference. It has its own two quarks, bottom and top, and its own tau neutrino. Okay, this is third family. So you can think, well, there will be a fourth family, a fifth family, but no, there are three families. There is overwhelming evidence that there are just three families in nature. There can be other particles. For instance, dark matter, probably the most plausible hypothesis for dark matter is that it's made of a particle which cannot be here. Must be of another kind. But it cannot be a member of the fourth family. That's discarded. That's excluded. So we have this funny thing. Three families of particles with growing masses, with a hierarchy of masses. Now, why this is like this? Nobody knows. So we can ask why. In fact, this is an active line of research in particle physics to understand why particles are organized in this way. But why we should ask? Why? Well, I think that the reason is that we are seeing here a pattern, and that pattern is telling us somehow that there must be some reason for that pattern. A pattern cannot. Our intuition tells us that a pattern cannot be just because. There must be some reason. But in fact, the reason to think that there must be some fundamental physics that explains this is not the lack of mathematical consistency. Our present theory for particle physics, which is the standard model, the so-called standard model of particle physics, describes very well these particles, extremely well. And there is no experiment which is in contradiction with the standard model. So there is no problem in that sense. There is no any observation which is in contradiction with the standard model. So in principle, we don't need to ask about why nature is in this way. However, we ask about that. We wonder why nature is presented in this way. So this is an example in modern physics in which the search for simplicity and the search for beauty, maybe it's not the same beauty as in art, I don't know, because I don't know really about art, but somehow it's a kind of beauty. Beauty in physics probably is more connected to, I would say that beauty of a model, of a theory, is more related to simplicity. And simplicity means economy of principles, but richness of predictions or results. Richness of phenomena that can be explained with just a few principles. The less principles you have, the better. Because the principles are the things that you cannot explain, because they are like axioms. So the less axioms you have, the better for you. Also, beauty is related to the mathematical structure. The more elegant, the more consistent is the mathematical structure, the better for the theory. In that sense, these two theories, general relativity and quantum mechanics, are superb theories. They are beautiful, they have economy of principles and richness of results. Probably general relativity is more beautiful than quantum mechanics in the sense that it has less principles and more intuitive principles than quantum mechanics. But on the other side, quantum mechanics is very powerful predicting things. The amount and the variety of phenomena that can be explained by quantum mechanics is absolutely incredible. There is no other parallel in history of physics. Okay, so both theories are really fantastic, but they are inconsistent between them. That's the funny thing. So I think I finish here. Okay?
Yeah. So now this is the problem for me here, that we have and you tried not to speculate about art too much. I will have to say something about my image of science there, but only because I'm trying to look at a space that could be opened up between these two strands we talked about. In a way, if I interpret you correctly, but please do challenge me on this one. In a way, we've got, despite all of this, a belief, I would say, in progress in knowledge, right? You're moving, despite these up and downs, you're moving into an area where you are consolidating and increasing the knowledge that's available. No? And I was trying to explain that, and in a way that is also not negotiable, within it, if you're not moving beyond it and increasing the knowledge about it. Whilst in somehow I was saying, that we have a situation where instead of all these prerequisites, we know this is the case, you build with these building blocks what it is you're building, and then you can ask the question. It's like all these blocks have been destabilized. We're asking questions in a situation where we moved into a much more precarious and much more uncertain situation. Where is art? Where is knowledge within that? And as a culture, we are in a situation where we have these, for lack of a better words, two extremes, you might say. One that is oriented towards creating the best possible knowledge of the world we can have. And the other one is actually interested in these the possibility of experience outside of any of these preconditions that you might tell somebody within which you can experience that. And what I was trying to describe is that this is actually a space where we can't even say art is on this bottom line, because the definition I've just given about this, that it is that, is also contested. There's a bit of a space here, I would argue, that is opened up where I, for example, am trying to articulate aspects of this. I'm trying to give examples in art or stuff we publish where those negotiations take place, where we are within the artistic paradigm, but we are not only in art production, where pieces of work are being made, where actually discourse and articulation of art and what it means are being part of this. And my question to you is, and we talked about this over dinner yesterday and previously as well, if you're looking at the making of science, not so much from the results as they progress over history, but if you're looking at this diagram you had, this kind of crazy mess of hypothesis and observation, is there not also a space actually within the sciences that, yes, the ideal would be to create this progression of knowledge, but there's a lot of areas, and increasing the amount of areas, where you're also in quite a murky zone, where it's difficult to say, is it proven yet that this is the case, or what are the best ways of doing this? At what point does a finding become relevant to other areas and so on? So the question we are raising, I think, lies somewhere in this overlapping area. How would a medium state of knowledge, where we are neither established what it is that we're speaking about, nor is it non-existent, actually take shape? How would we interact between those? Historically speaking, I would argue, we had this sense that there were people who seemed to know everything. There were artists and there were scientists, and they could bring this together in some form of body, of a human body that played in both parts. The complexities and the difficulties in this modern world has become so great that we don't imagine one person to actually cover this whole area. So we as different cultures, institutions, have to find ways of negotiating this. And secondly, that's an effect that I have in our field. So if that is the line of art here, so you're a highly paid contemporary artist, if you're moving into this area, you know, you're doubted. Artistic researchers, because they're not as strong on the market, they're not as strong in the space of art production, they're explaining art in some ways, you know, are being doubted as to where they stand as artists. It's very tricky sometimes when you do a doctorate, for example, in fine art, to explain why that is necessary, because everybody else who made on within art, you know, did it with an MFA, for example. So there's an issue around hierarchies and whether this middle ground is actually seen as worthwhile, whether it's achieved by its own right. And likewise, I would argue, and you would have to answer this question to me, if somebody was to operate within the sciences on an area where they are not fully in tune with the orthodoxy of the science, you know, you might also talk about them in derogative terms, like a charlatan maybe, or somebody who is just not as knowledgeable, you know, or somebody who not good enough to do proper science, so they speculate in popular books about it. There must be a whole area within scientific work that is also dubious, to put it, you know, least. It's still oriented towards the high achievement, like art is still oriented towards the high achievement in art, but why is there a whole space in between that culturally we don't yet see as something in its own right that actually contributes to an exchange and a shared understanding that we individually don't seem to have anymore? So to the artists in the audience, what I said may have been quite clear. To the scientists, it might not have been, and vice versa, I would argue. And this is kind of the point here. So what would be the conditions at which this dialogue can be had? And I think your project and the whole series around the knowns deals with the fact, not so much what we know or don't know in our strands, but actually what it is that we can bring together in these kinds of shared definitions of a space where we could meet. So that's kind of my question, and I would really like to discuss this, because we did discuss this in various modes, and that is the key question. You know, if we're having two very different paradigms, like we presented them, how would we create this and discuss this shared ground, that we are still part of a culture and we are still operating with the same languages and similar concepts at least, or are they just completely separate and this is just not existent, which means we're just going different ways at this point. Anyway, so this is kind of my bit at the end, and I'm very interested in the discussion of this, because this is unresolved.
Okay, great. Well, thank you both for those really provocative provocations. And I think that this question that Michael has generously thrown out to everybody is one, yeah, I'm also genuinely interested in, and I'm glad that you mentioned my project in this context. So that is some good news. I have a question, but I also am counting on all of you to have a question, and I would probably be more interested to hear from you, partly because we've been kind of in a dialogue since before January, I think it's sort of, or before January, and I want to kind of share these generous thinkers' minds with all of you. So if somebody has a question, we do have a question. The only thing I'm going to ask is if when you ask the question, if one of you could repeat it, because we don't have a microphone that will be on the recording. So we're going to do a slightly strange activity where you will say your question and then one of you will repeat it.
Okay. About the last question that you said, I think that sometimes when as artists lay in the line of art, I believe that sometimes art becomes too much meta-artistic or self-reference. And I do think that the integration of other knowledge in the practice enriches a lot the final work that we show and that we share. And yes, how do you think that that is not accepted by the artistic community? Because I don't understand how it could be like harmful for the view that the external art community has for us.
So you're describing art as potentially too self-referential. So this kind of high art we see in contemporary art, Banyal say, and you're saying that in fact there's a lot of openness of art towards the people and other areas, and you're asking now, why is that not stronger reflected in the notion of contemporary art I put forward? Is that the question?
Yes.
Oh, good. Now, I think it is, but the question really is, why would people struggle with what you called the self-referential here? So we could, of course, have an image of contemporary art as doing precisely what you said. And on the face of it, it does that. I mean, there's a lot of socially engaged art. There's a lot of open structures, you know, people can partake. I mean, go to any major art event and you'll find loads of spaces for that to happen. At the same time, the question is, how much do these contributions matter to art, right? In your experience, you know, sometimes people feel they are a necessary part of what's presented, but they don't change anything about the art. You know, the artist does what they do. They stay within their paradigm, and audiences and the concerns they have are secondary to this. And I would share this, that actually there is an element, and I've described it a little bit in this diagram here, coming from the history, that artists today who are operating on this territory, they're not only serving the communities, they're also serving the history of art and their place within the history of art. And there is a contradiction if you're insisting on the one, you know, and this is your concern, self-referentiality, as you put it. It can be difficult to step outside of this. So, for example, if I'm saying I'm interested in research processes in other disciplines, you know, where is the place of this, you know, within contemporary production? I would have to bring that back into something that serves the history of art, right? And the question I'm raising is, yeah, it's possible. So anything we do in experiments, we can bring back to science or art. But is that the only interesting part for us? That we have to go out and harvest, you know, these new experiences, but we keep serving the same paradigm? Or is something happening in this contemporary moment where we are rethinking whether it's more important to have this kind of practice and building up a new definition of what it means to be an artist today, compared to serving a particular history of art where we have to, in a way, operate with identities. This is a work of art, you know, this is me, an artist, this is an object that has to be somehow valued in particular ways over those interactions I take with other people in other disciplines. And that question, that tension, whether or not art is actually still, you know, part of a lived world, or whether it is actually too much obsessed with its own market and its own history that it puts into this place, and therefore out of touch sometimes with what's happening. But also maybe not open enough to these new influences and new knowledge that come from somewhere else. So this is kind of my point, and depending on where you stand with regard to contemporary art, you might say, right, yeah, there's a criticism to be mounted, you know, that on the surface they are engaged, but in practice it doesn't go far enough, you know. But that is what you'd like to do. You would like to enrich that. Or where you say, actually, we have to get rid of some of these encrusted notions of art where we have to find these representational forms. We have to come up with an object or a performance that is it. We have to come up with a formula that is it. We can't do science outside of this, or we can't do art outside of this. And that's kind of my question, whether scientific activities that doesn't produce results, and artistic activity that doesn't produce results, has not a value in its own right. Because the interchanges and relationships seem to happen at that point more than between the results that we are producing. Sorry, a bit long answer.
No, thank you. Thank you. It's really useful. Patrick,
Yeah, I also have a question to you, Michael.
can you speak a bit louder, sorry?
Yes. I also have a question to you, Michael, more about what you described here. And how do we know the artistic process of when something passes into art? And if I understood correctly, the way it works is like you have a creative process or something, and then if something self amplifies, or then if it gets registered and gets noted, that's the moment when you say that something can pass into art. Like, for example, with your example, when there was this photograph of this piece of art, and in this magazine, that was the moment when it actually passed into art. So maybe making the analogy with what Alberto said before, in physics, we always have as a reference point nature. So any model of physics actually has to pass the experimental test, and that's when we can decide if this is a theory of physics or not. So in a sense, what I'm wondering is, in this process, you say it's registered when it's described, but so who's the reference point? Who decides? Like, who registers this, and who then decides, now I define this as art? Is it the artistic community? Is it everybody? Or is it somewhere in between? Like, when you say now it's actually worth of calling it art, because, for example, if somebody who's maybe not in the artistic community would take a picture of something and describes it, would this then also mean that now it is registered as a piece of art or not?
So the question is, when and by whom practice and production within art is registered as... Yeah. Now, first of all, I was trying to highlight really it's distributed, which means that there is not a single point at which that takes place. So, for instance, he may put that up in his studio, and he may, have printed some other stuff that might have been destroyed later. We don't know. We all do stuff in the studio space that has no future as such. So the one we pick out, or the one formula maybe you pick out, it's just the one that has stuck. The others that didn't stick, are not being taken up for those reasons, because they've weren't relevant, right? So we shouldn't look at this process from the end, where we only look at the documents that we have, but actually the various attempts in creating and stabilizing objects that can be in some form of circulation, being shown in some way, or being, And the point I was trying to make there is that these are always acts of articulation that impact on what the work is becoming, right? It's not this idea and then it's being published and then it's being registered, but it's actually in this act of making it that it becomes articulated and has a certain possibility of being seen as contributing to art, right? So, and the question there is, you might say there are certain authorities, and there are certain authorities historically, so critics or, curators or whatever. And again, it's true for, in a way, this strand here where we know there are these kind of cultural tests, you might say. But the question is that sufficient when we talk about the knowledge contribution and the world engagement artists bring to the table? Meaning, is only the practice that is registered like this kind of relevant, or is there a lot of art practice happening that that doesn't lead to those kinds of historical mappings of where your practice lies? And then it becomes more difficult because there's a lot of ignorance, a lot of stuff we don't know, a lot of practices we don't know. It's quite a murky field, and people have different opinions there as well. now if you're looking at the recent kind of AI debates about, pictures that are being made that look exactly like an artist might have made them, but is it art? Who's choosing this? The point is that here we've got again an output that's being put in front of you saying, well, here's a piece, is it art or not? Where in fact the artistic process is not like this. We don't have this single output and say, is it art? Like people laugh about this fountain kind of urinal ready-made still, because the question isn't, is that art, but how is that made to be art, right? And what strategies have been in place? So it's just a kind of so for me, the question is what nature is in this case, whether it actually would, hand on heart, for you be a singular voice that would define that, or whether not it's a much more contested and difficult field to say, what really sticks and what doesn't stick. How far does a hypothesis go? It might be, say with the one with light you mentioned, it might be complicated 100 years down the line. Something may or may not keep being registered as such. And likewise we have that there. So it's a messy place really. It's not such a clean line. And all I'm trying to say really is whether the narrative we have when we talk about science, or the narrative that we have when we talk about art as these kind of clean trajectories, of a certain type of progress, a certain type of specific positioning, it's really reflects the reality of the work. And if you look at the reality of the work, what might be the overlapping or shared grounds? And I would argue you also would have, articulation of matter in experiments. You would also have certain agreements or disagreements with your colleagues. You would have future experiments or tests to work something out. You would try it in a journal and see whether the reviewers accept it, and so on, until it's eventually established. You will lose some qualities of the work because this bit interested you, but people weren't interested in it. It was just you. So kind of lose that part and you do something else. And this kind of messiness until it's finally established, And then when you say, I don't not only want to accept what somebody else says, that it's established on this ground, I believe it, but you want to say, I want to prepare the ground as well on which the work will be established. Because there is no notion of art that predates what I will present and make you believe that this is art from this moment onwards. So, in some sense, how does physics, for example, change by any of these developments have taken place? Anyway, long answer again, but it is the complications, taking on these complications and not idealizing a notion of art or a notion of science. And the question then is, if you do that, what's the result for your understanding of what science is or what art is, and for the practice you're doing at this moment?
Maybe have time for one more. Yeah.
Okay, I'm going to try and articulate this simply. So, the place that you were talking about, Michael, of being in a murky ground of perhaps knowing or perhaps not knowing, when you were talking about, I suppose the way that the concept of art is constantly shifting. It kind of made me think of my layperson's understanding of quantum theory around things being and not being at the same time. With Schrodinger's cat. I'm not questioning at all, but I suppose, I'm kind of curious about that. Is there a connection, I suppose, there between a place of kind of both knowing and not knowing? Sorry, that's just probably not a question.
Would you like to repeat the question first of all?
Well, maybe I can relate your question to for instance, the principle of uncertainty, which was thought the first time by Heisenberg, which sometimes is presented in the following way: you cannot know at the same time the position and the velocity of a particle. If you know one, then the other one is confused or is uncertain. Okay. Well, this is intuitive, but in fact, this is not what the principle says. What the principle says is that the nature of a particle, the nature of matter, is in such a way that if, for instance, a particle has well defined the position, it has not well defined the velocity. It's not that it has a velocity and we cannot know the velocity. It's a limitation in us. No, no. It's that the particle has not well defined the velocity. They are somehow incompatible, or to some extent incompatible observables, incompatible magnitudes. Okay. So in that sense, it looks like quantum physics gives room to this knowing and not knowing, but in fact it's not like that. The fact is that nature is not as it seems in our scales. At our scales, which are macroscopic scales, things have well-defined positions, well-defined velocities, but when you go, for instance, to microscopic scales, you discover that nature is not like that. This is just an optical illusion in our macroscopic world, but nature is more strange than we thought. And the only possible way, as we have found, well, the genius have found, no, to describe that kind of behavior is using mathematics as a tool to express how nature behaves. So that would be my.
Well, I mean, I was hoping a lot along these lines. It's very difficult to ask the question. I'm completely with you there, because for that lay knowledge we have. But nevertheless, if you were to accept that nature not only behaves in this or this way, but it's actually articulated under specific conditions itself in this and this way. So depending on the conditions you are setting up for it, nature will articulate something, right? And you will read this off and say, okay, I've got the place, but maybe not the velocity. So if you're switching from it is like this to in this specific instance, because the conditions are like that, would it articulate itself like this? And with this articulation comes necessarily a dimension of not knowing. You cannot have an articulation of nature that is fully transparent. This is how I interpret your interpretation there. So whenever we look at description of nature that are certain, at least on the quantum level, we would have to also say that as we say this, there's a dimension to this where, because we create certainty here, we have to accept not certainty in some other areas, a fallout in a way of this. So I know it's not possible to do, and I really apologize, but whether or not along a line of certainty, of developing knowledge, we have necessarily an area where we are having to deal with. At the same time, we cannot transfer everything into a transparent knowledge of this. We are constantly dealing with the trade-offs that come with that. I think that's behind the question. At least for me, it is that I think is there a space, or I'd like to ask the question, whether some of these findings, for example, around the quantum level we just referred to, can be somehow or have to be translated into the science itself, so that you would also have to find ways in which not just to articulate what is certain, but also articulate what's uncertain, as you do probably in probability calculations, including other areas that are maybe not expressed as such. So how would you engage with the side effect of uncertainty in your practice as a scientist? It's really difficult to phrase that, but this is the hunch as well I have there, that if we accept an aspect of nature is uncertainty, how is that reflected in scientific practice?
Well, I think that even for the uncertainty, we look for rules somehow. For instance, when you have a particle in a superposition and you measure the position of the particle, it can appear either here or here with some probability. We cannot predict the position of the particle, but we think that this is not because we don't know the position of the particle, it's because the particle has not a well-defined position. So what we try, or what physics has tried to do, I think quite successfully in the case of quantum mechanics, is to find precise ways to predict the probability with which you will find a result or another. In that sense, quantum mechanics is a very precise theory because the probabilities can be measured with many digits of precision, and they work. So I think the aspiration of physics is always to describe nature with laws. Even if the behavior of a particular system depends on the conditions, which certainly you are right, it depends really on the conditions, you are trying to describe in a precise way how the conditions affect the evolution of the system. This is the game of physics. But well, it's interesting that maybe physics has been attached to mathematics as the main tool. I think it's because nature has taught us that it's the right way, or a very powerful way to describe nature is with mathematics. But maybe there are areas of nature that we cannot access to them just with the mathematical tool. We need something else. I don't know, that's a possibility, and in that sense I think we should be open to anything, because I think that the essence of science, as I said, is the feedback between experiment and theory, not necessarily a mathematical formulation. If we use mathematical formulation, it's because nature tells us that use a mathematical formulation. But I think that in principle, I think we are open to everything. Yeah.
It would at least, would at least, you know, kind of destabilize, if you said this, destabilize in a way this ideal that it has to be expressed mathematically, right? I mean, this is kind of the doubt or the question, you know, that what other avenues might there be, and if you're looking at some equivalence, you know, in other fields of.
By the way, can I ask you a short question about your diagram? You said that long time ago, a human being was able to work both in the artistic realm, so to say, and in the scientific one. I don't know, maybe people like Leonardo, people like that, no? But you think Leonardo was doing something that was at the same time science and art, or he was a genius that was able to do great works in art and great works in science?
Well, the problem is that the notions weren't as settled as they're today. You see, today the notions are settled in such a way that you could challenge, you know, his scientific or artistic status. So maybe more an engineer than a scientist, or maybe more a draftsman, you know, than a contemporary artist, or whatever, you know, you might put there. But it doesn't matter, because at the time, those notions of science and art weren't developed like this. Within whatever was developed at the time, it encompasses what we today would call science and art, right? Now, this is part of the problem, that if we are describing our concepts of the disciplines in such extreme ways, as we've demonstrated we do, you know, those positions become increasingly impossible. And my question, culturally speaking, is, you know, whether there's some responsibility in the following up from your first question there, for art or for science, to also look at how these fields are connected, because I mean we're living in a shared world, right? Where we know that an individual person cannot connect it like this anymore, because the definition of the concepts are so opposed to each other, and the practices are so opposed to each other, that it's not feasible. I mean, you know, I cannot be a scientist, and you probably can't be an artist in the way that it comes with those hard conditions we put ourselves into within those fields, and that really is the question: whether what can we find that has any resemblance to a some form of bringing together of these highly fragmented and very strong separate definitions within the field of knowledge. And I mean, I don't quite know the answer, but in the projects themselves can be more or less open to those exchanges. And I think with your work and with other work, you know, we keep testing this, you know, and see what happens. So what I would hope to get from you and from you guys out of this is, after the project is finished, to actually get a sense of what was the meaning of this project, both for your practice as an artist and the artworks you created, but also did anything change in the way you as scientists interacted when an artist in the room? And how does an understanding of the very notion of what it is you're doing here maybe change? And that's kind of what another historical project, what we have to work on, I think, for quite a while to come.
Thank you. Yeah, that's sort of what I have coming up in my in my workload for the next few weeks. Yeah, to really think about what it's meant for me to be here, what it's meant for the people that I've been intervening with, or who've been listening to me in different ways, or I've been listening to them, and to try to also think about a kind of register or registers of that. But I want to first, before we thank our generous offerings from today, I would like to just remind everybody that the plan, once we've given our thanks, is to go in a kind of procession-like format to the Plaza Mayor, which is not the one in the center of Madrid, because that would be a really long way to go, but it's the one in the center of the campus of the Autonomous University of Madrid, whose boundaries we are within. And on the top floor of what looks like a kind of spaceship sort of structure is a exhibition space where there is the exhibition that is called Escuchar la Materia Oscura, or Listening to Dark Matter. And I would really like to invite you all to join in that act. Just to say, the person who gets there first has to phone a number so we can get in to the room, because a strange event happened where the invigilator, who was 20 years old, retired recently, and that's another kind of mystery that we are dealing with these days. So I'd like to just say a big thank you to Alberto, to Michael. Please join me in thanking them for their time.